is 4 and 6. So 2 twos are 4, 3 are 9 and 2 ones are 8 and 6. We have 3. So the LCM is how much? LCM is 22 is 4 and 4 is 12. So now the LCM is 6. What you need to do here is a Raji. It was so you multiply by what's to consider 3 pieces. So that we get 3 pieces of chalk. Okay. Sheila had 1 by 6, so we just to start first 11 by third. So by 3, by 3 so that means it's with about 4 parts. Sheila had 1 by 16 by 3. So she got pieces. So now you have to find how many pieces she ate the remaining part. So how many pieces chocolate did each one get? So Raji got 3 pieces. Raj got 3 pieces. Siddharth got 4. Sheila got 3. So how much did Manju get? So you add all of them. 2, 3, 5. 5 plus 9 is 12. Sorry. 2 plus 3, 5, and 5 plus 4 is 1. So, so she got how many pieces? She got 3 pieces. Okay, is that clear? So, whenever you have a question like this, you find the LCM, then you divide it in portion. Okay, so I get blue one. Okay.
Hello, Afshin, am I audible?
Hello, ma'am. Yes, ma'am.
Afshin, are you in the C5 batch? No, right? You're in the C4 batch.
Yes, ma'am. But I changed, so now I'm this batch.
But this batch is going like much more ahead than your batch. So we are already on the fourth chapter, and in your batch, we have not even finished the third chapter. So how will you be able to manage it up?
Uh,
Why did you change?
well, I'm having face-to-face tuition, and that doesn't suit the timing of the other batch. So that's why I had to change.
You are having what
Face-to-face offline tuition.
for?
So for maths.
Okay, so that does not suit the timing of the. Okay, but bache, we have started the fourth chapter here. Acha, okay, we'll see. Okay, don't worry, we'll see what can be done.
Okay.
Just give me 2 minutes so that others can join, and then we'll start. Okay.
Okay.
Okay, Afshin. So let's start with our class. Uh,
Okay, ma'am.
Now just tell me one thing, bache. From the third chapter, the main topic, that is the chemical properties of metals and non-metals, that is left, right? We'll be starting that topic in the next class. Okay, just 1 second. Yes, okay. So just tell me one thing. If Abdullah joins right now, then we can start with the fourth chapter. But if you feel like, should we start with the third chapter, or should I start with the, fourth chapter itself for you? And whatever part is left from the third chapter, we can do that after the fourth chapter.
We'll do the third chapter.
As of now?
Yes, ma'am.
Okay. But then if Abdullah joins, we'll have to start with the fourth chapter.
Yeah, it's fine, ma'am.
Ajay, so let's do one thing, okay? Let's start with the fourth chapter, okay?
Okay, ma'am.
So that I'll teach you this part specifically. Where is Afshin? Hmm. And so I will tell you this thing, okay, which is the starting part of the fourth chapter. I hope you don't have any exam in the nearby dates.
Yes, ma'am. I have periodic test, unit test.
Okay, when is it?
December 3rd. Starts from December 3rd.
Okay, and could you please tell me of the syllabus?
I have metals and non-metals from chemistry.
Hmm. Fine, we will balance it. Inshallah. Yes, Abdullah, please, Afshin and Abdullah, both of you turn the camera on and unmute yourself. Okay. So basically, yes, Abdullah, your device is fine now. Your camera has finally started to work.
Yes.
Okay, good. Abdullah, I think we'll just take 5 minutes so that I can quickly revise this part to Afshin, and then we'll start from the main part. Okay.
Okay, ma'am.
See, Afshin, in the third chapter, we learned about the ionic bonding, right? When how do metals and non-metals react? That was the ionic bonding. So basically, what was happening here? Transfer of electron was taking place, and the bond formed and the complex formed, the compound formed was what? Electrovalent or the ionic compound. Okay. Now, for carbon, which is very specific kind of an element because of the properties it possesses. Okay. And that is why we have a separate branch to study the compounds made of carbon. And that branch is called as organic chemistry. Fine. So let's see exactly what is happening in the organic chemistry. What is the foundation of organic chemistry? So it is all related to the properties of carbon. Okay. So let's see how does carbon bond first. So carbon has 2 and 4 as the electronic configuration. If 4 is the valence electron here, okay, it can either lose 4 electrons or it can gain 4 electrons. In either ways, if that happens, there will be too much of charge for it to be stable. Okay, if it loses 4 electrons, what will happen? It will still have 6 protons, okay, which will give it a charge of +6, and it will just have 2 electrons. Okay, so it will be a very unstable force here. Whereas if it has 6 protons and it gains 4 electrons, okay, it becomes 10 electrons. Clear? Again,
Yeah.
not very stable. So therefore, this transfer of electron system is not really working fine with carbon. So instead, what does carbon really do? See, carbon bonds through covalent compounds, through covalent bonding. Covalent bonding. Okay. Now, what is covalent bonding? Instead of complete transfer of electrons, we are having sharing of electrons. We are having sharing of electrons. Okay. Now, let's see how does sharing of electron take place. We'll take a very simple example. One carbon atom has 4 valency, right? This. So this point is very important. Throughout organic chemistry, you will use this part of carbon. That is, one carbon atom has 4 valency. Okay, that means it has 4 arms with which it can bond. Correct? Afshin, understood?
Yeah. Yes, ma'am.
Fine. So let's see now what is happening here. 4 carbon atoms. Okay, sorry, 4 electrons. We are just concerned with the outer shell. This has been discussed in class 9. Now let's see exactly what it can do. It has 4 electrons. It needs 4 more electrons, right? It needs 4 more electrons. But if it loses or gains 4 more electrons, that is not become very stable. So rather, what does it do? This is one hydrogen atom with 1 electron. This is another hydrogen atom with 1 electron. This is another hydrogen atom with 1 electron. And this is another hydrogen atom with 1 electron. You see now what is happening here? This carbon atom, okay, it has 4 here. It will share this one. Okay, this one. It will also share this one. It will also share this electron from hydrogen, and it will also share this electron from hydrogen. Correct? And what is happening for hydrogen, bache? See, it is also having 2. It needed 2.
Yes,
See,
ma'am.
correct. So what do we see here? Basically, this one bond has been formed between carbon and hydrogen. What is the valency of carbon? 4. So how many bonds does it need? 4. Okay.
4.
Yes. This one bond formed by the sharing of 2 electrons. 2 electrons give rise to one covalent bond. 2 electrons give rise to one covalent bond. Is it understood?
Yes, ma'am.
So this is one property. The other property is, so this is the covalent bonding. So let's quickly see the covalent bonding in nitrogen. Okay. So nitrogen has got 3, this thing. Okay. 1, 2, 3, 4, 5. It needs 3 more electrons. So what will it do? So it can again bond with 3 hydrogen atoms. 1 bond, 2 bonds, 3 bonds, right? If it
Yes,
is
ma'am.
forming 3 bonds, it will have 8 as the complete valency. Understood? And this is by the sharing of electrons. So how many bonds are here, Abdullah?
Yes.
How many bonds are here? How many covalent bonds could be seen in NH3? 3. What are the number of electrons being shared?
2, 3, 4.
If there are 3 bonds, but just 6 electrons are being shared. See, 1, 2, 3, 4,
1, 2,
5, 6.
3.
One bond
Where can
means
you
2
show again, ma'am?
electrons.
Can you show again?
Yeah, yeah. See, one bond, one covalent bond. Okay, we are specifically talking about a covalent bond. Means 2 electrons are there. Huh? See, 1, 2. These two together form one bond. These two together form one bond, right? And these two together form one bond. So if you are having 3 bonds, how many electrons are in sharing? 6.
6.
Okay, and if you see nitrogen wanted to have 8 to complete the octet. See, 1, 2, 3, 4, 5, 6, 7, 8. Is it complete? Yes, it is complete. Understood, all of you? Both of you?
Yes, ma'am.
Yes, ma'am.
Fine. Now let's come to the next part. So, bache, Afshin, what you will do is that you will go through the starting part. I've told you the basics here. Okay. So these
Okay,
are
ma'am.
called as covalent compounds. Okay. And the covalent compounds have properties different from the ionic compounds. Basically, the covalent compounds will have low melting point. Okay. They will have very low melting point instead of the high melting point that we saw in the ionic compounds. Why is it why is it so? Because in case of ionic compounds, what was the force between the ions? What was the force combining the ions? Yes, Abdullah. Hmm.
Can you say again?
Name the force present in the ionic compound.
Name the four.
Hmm.
Um,
Electrostatic force of attraction, which is a very strong one. Therefore, in the ionic compounds, we need a lot of energy and they have a high boiling point, therefore, okay? But in case of the covalent compounds, that is not the case. Fine. See, these are largely non-conductors of electricity. Why are they non-conductors of electricity? We don't really have any ions here, Afshin. We don't really have any ions here, right? There is no
Yeah.
full formation of ions by transfer of electrons. There's just sharing of ions, sharing of electrons. Okay, so there's no formation of ions. Therefore, there's no conduction of electricity. Therefore, the organic compounds and the covalent compounds are basically majorly non-conductors of electricity. Fine.
Yes, ma'am.
Okay. So that's it. You will go through this. I've discussed all of these things here. See, hydrogen itself can bond. How do we get this molecule H2? See. This is one hydrogen atom with one electron. This is another hydrogen atom with one electron. Both of them need to have two electrons in their shells. Okay, in their shells. What will it do? See, this will share with this one. And how many bonds will be formed here, both of you? Please answer. How many bonds will be formed here?
uh, two.
2.
What is this? H2. How many bonds?
2.
One bond. How many electrons? Two electrons. Huh? But
Uh,
just see, there's just one bond, right? Fine. Moving on to the next part. You see here? You see here? Okay, shared electrons. H2 molecule shared electrons means two electrons are shared. So how many bonds are there? One bond. Okay. If let's see for nitrogen, okay, N2. So N2 is the molecular formula, right? N2 is the molecular formula for nitrogen. How are these molecules formed? The elemental molecules, how are these formed? That is through the covalent bonding. Okay. So let's see how are they formed. So one nitrogen atom, 1, 2, 3, 4, 5. Okay. See here, one bond can be formed like this, another bond, another bond. Yes. So how many electrons are in sharing here?
6.
How many bonds are there between these two nitrogen atoms?
3.
Three. So can I say it is nothing but N2 formed by the covalent bonding or the covalent sharing of electrons?
Yes, ma'am.
Understood, Abdullah? Understood, Bache?
Yes.
Okay. Similarly for oxygen, Afshin, can you work that out? Okay. See, this is something that we have discussed right now. Okay. Coming on to the next part, that is versatile nature of carbon. So I was discussing the same thing, that what is it in carbon that leads to so many different compounds being formed? Okay, that is nothing but just the properties of carbon. How does it bond? Why does it bond? Okay, how does it react? What is the energy it is having? What is the size of carbon? So all of that is affecting its properties. I mean, therefore, its behavior. Okay, see, if you know that the amount of carbon is really less in the atmosphere, carbon dioxide is just 0.03%, right? In the crust also it's rarely there, okay? In very small amount. But 99% of the compounds known to us, they are the organic compounds. So what is it in carbon that is giving rise to such large number of compounds? So let's see. Carbon has a unique ability to form bonds with another carbon atom, very important, and this is known as catenation. This is known as catenation. Carbon can keep on bonding to carbon, 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 carbon atom. And this property of self-linkage, it is called as self-linkage. What is it called as?
Self-linkage.
Okay. basically bonding to itself, linking to itself, self-linkage. Okay. Carbon atoms, and this property is called as catenation, and this is highly possessed by the carbon element. These compounds may have long chain of carbon that we will discuss later. Compounds of carbon which are linked by only single, this also I will discuss later. Fine. Now you see, if you see that silicon also has something electronic configuration like this, right? Carbon has the electronic configuration as 2 and 4. Now both of them have 4 electrons in their valence shells, right, Abdullah? Both of them have 4
Yes.
electrons in their valence shells. So silicon should also give the same result. Silicon should also give the
Can you
same result.
repeat?
Yes. I'm saying carbon and silicon, both of them are having 4 electrons in their valence shell. Valence shell means the last shell, right?
Yeah.
So both of them should give the same result in terms of forming a compound or a chain, self-linking chain, right?
Yes, ma'am.
Yes, Abdullah? It does not happen. Why does it not happen? Because see, the size is different for carbon and silicon. The bonds formed from silicon can majorly form a chain up to max 6 to 7, 8 silicon atoms, right? Why? Because of the larger size, it can break off it is very reactive because of the large size. It is very reactive. Silicon forms compounds with hydrogen which have chains up to 7 or 8 atoms, that's it. But these compounds are very reactive because of the large size, obviously. The carbon-carbon bond is a very strong bond and hence very stable. Carbon is smaller in size, the bond is more strong, therefore it is very stable, therefore many carbon atoms can join. Unlike in silicon. I hope that point is understood by both of you.
Yes, ma'am.
Just 1 second. Yes, okay. So come to the next point. This gives us a large number of compounds with many carbon atoms linked to each other. Now, since carbon has a valency of 4, it is capable of bonding. It is called as tetravalency. What do we mean by tetravalency? Tetra means 4. Tetra means 4. Valency means combining capacity. I think you all have learned this in the class 9, third chapter. Valency is
Yes.
nothing but the combining capacity. So carbon can very easily bond with 4 other atoms. Okay, that could be any other atom. That could be carbon atom. That could be hydrogen atom. That could be nitrogen, oxygen, any atom. Okay, and those bonds are quite stable. Others can also form, but those are not stable. Correct. So compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, many other elements giving rise to compounds with specific properties. That's it. So many compounds just because of these different properties of carbon atom. See, one reason for the formation of strong bonds by carbon is its small size. This enables, how does the small size help in the formation of bonds?
Can you repeat, ma'am?
How does the small size of carbon helps in the formation of stable bonds? See,
It
this enables, say,
it like
say that without any hesitation.
it like
Mm-hmm.
it like allows the nucleus to strongly attract the shared
Hmm.
electrons.
Right, it does that. Therefore, very stable. Bonds formed by elements having bigger atoms are much weaker. Afshin, is that clear to you? Good, Abdullah.
Yes, ma'am.
Now let's come to the main part, and that is this. So I'll be starting with the basics here. Come to the main part, that is organic compounds. What are organic compounds? compounds made up of carbon bonding. Okay, compounds made by carbon bonding. So we can have many different compounds, types of compounds. One very important type of organic compound is the hydrocarbon compound. Hydrocarbon compounds. I would advise both of you to be very attentive. These are the basics. Please try to understand them. Now, what are hydrocarbon compounds? Basically, when compounds formed by hydrogen, carbon and hydrogen bonding. Carbon and hydrogen bonding. Okay, so the smallest part here, see, 1, 2, 3, 4. This is a carbon, hydrogen carbon bonded compound, right? Yes. How many carbon atoms are here?
1,
How many hydrogen atoms?
4,
Okay. So basically, what happens if I increase the number of carbon atoms? It will be something like this. If we
Oh,
have two
yes.
carbon atoms bonded to each other, now you see each carbon atom has a valency of 4. It cannot have more than 4 bonds, each carbon atom, okay? So let's name them as the first carbon atom, the second carbon atom. How many hydrogen atoms does each carbon atom need here?
3, right, ma'am?
3,
So 1, 2, 3, 1, 2, 3, these will be hydrogen atoms, right? Now you see. So this is also a hydrocarbon compound. If we have 3 instead of 2 like this, this is the first carbon atom, the second carbon atom, the third carbon atom. So how many hydrogen atoms does the first carbon atom need?
3.
3. How many hydrogen atoms does the second carbon atom need?
2,
2.
Brilliant. The third one?
3.
3. Okay, fine. So let's. Now basically what is happening, we can have compounds with n number of carbon atoms. We can have 7 carbon atoms. What will happen? This is also possible, right? What is stopping the linkage, carbon linkage? Nothing. We can have any number of carbon atoms linked together to give you the compound. Now, let's see for this carbon atom, how many hydrogen atoms are needed here? Abdullah, anything going very funny?
No, ma'am. This is my mother.
Mm. Yes, how many hydrogen atoms will be needed for this carbon atom? The one I
2,
marked
2.
here. 2. Okay. And for this one?
3.
3,
For this one?
3.
3,
3. Okay. So likewise, we can have any number of carbon atoms, and through that we can have the hydrogen atoms attached to each carbon atom respectively according to its valency. Right? Now let's see. These are called as hydrocarbon compounds, and these compounds could be saturated or unsaturated. Please try to understand, very important. See, saturated means full, unsaturated means not full. Now let's try to see what is happening. And it is based on number of carbon bonds between carbon atom. Now let's see exactly what is happening. So let's suppose for 2 carbon atoms, okay? These were the 2 carbon atoms. We needed 3 hydrogen atoms for each carbon atom, right? Now let's say if I make 2 bonds between 2 carbon atoms like this, then how many carbon atoms, how many hydrogen atoms does each carbon atom need now?
6,
See, this is one carbon atom. It has how many hands? 4. 4 is the valency. So out of the 4, 2 have been bonded with the second carbon atom. How many hydrogen atoms does it need now? Each carbon atom?
4, right?
Each carbon atom. This is the first carbon atom. This is the second carbon atom. Tell me how many hydrogen atoms should
6,
I attach to the first carbon atom, bache?
3.
3. That is it. If you see here, this is the first carbon atom. Okay, first carbon atom. 1, 2, 3, 4 bonds. Okay. Instead of attaching all the hydrocarbon compound, all the hydrogen atoms, okay, what I did was I joined it to another carbon atom like this. Now we only needed 3. Afshin, yes, we only needed 3.
Yes,
Now
ma'am.
what is happening? Instead of this, what I'm doing is that I'm joining one more bond to the second carbon atom that we have in the compound. Now tell me how many hydrogen atoms do we need here?
2.
2. For the second carbon, total of 4 bonds, not more than that. 2 are already bonded to the second carbon atom, to the first carbon atom. How many hydrogen atoms needed? 2. Correct? Understood? Afshin?
No, ma'am. I did not.
See, let's take one more example. How many carbon atoms are here?
3.
3. Now you told me that the first carbon atom, the second carbon atom, the third carbon atom. The first carbon atom and the third carbon atom needs 3 hydrogen atoms each because one of their bond is bonded to the second carbon atom, right?
Yeah.
The second carbon atom needs just 2 hydrogen atoms because 2 of its bonds are already there, right?
Yes, ma'am.
Now see what happens. 1, 2, 3, 4, 5. Like this, correct? Now what
Yeah.
happens? If I bring this bond here, that is, I bond this carbon atom to the third carbon atom via 2 bonds. How many bonds is it left with? You see? So this bond is not there now. Also this bond is not there.
Yeah.
Understood, bache?
Yeah. Yeah.
So Abdullah, how many hydrogen atoms will the second carbon atom need?
2.
Second
No,
carbon
no.
atom.
1.
Why 1?
Because the 2, the second one is attached to third, 2 of them, and one of them is attached to 1. So that's why
Hmm.
we need 1.
Yep. So out of the 4 bonds, it already has 3 bonds bonded to the respective carbon atoms. Its one bond is free and we will bond the hydrogen atom to that bond. Afshin, is that understood?
Yes, ma'am.
Okay, now let's do one more thing. How many carbon atoms here?
4.
4. Now the first and the fourth, so this is the first, this is the second, this is the third, this is the... I think here you will say that the first and the fourth carbon atom needs 3 hydrogen atoms each. The second and the third need 2, right? Let's do one thing. Hmm. Let me just draw this properly. It was already there. I made 2 more bonds between the second and the third carbon atom. Each carbon atom can have a maximum of 4 bonds. That's it. Now let's see how many carbon atoms needed for each carbon atom. The first carbon atom,
3.
very good. The second carbon atom,
Oh, none.
none. Excellent. See, 1 bond, 2 bond, 3 bond, 4 bond. Afshin, understood?
Yes, ma'am.
The third carbon atom, none. See, 1, 2, 3, 4. It already has 4 bonds. Its 4 bonds are already bonded. It cannot have any other bond. The fourth carbon atom,
3.
3.
if I change it like this, now tell me for each carbon atom. The first carbon atom, this one,
3.
huh?
1.
Afshin, why 3 and why not 1? And why 1 and why not 3?
Because ma'am, the bond for the first one, the bond is connected with a second one, and
Yes.
they are like three connected.
Hmm.
So the first one, it needs one bond.
Yes. It will just need one carbon atom. Actually, now you will tell me the second carbon atom. How many bonds it have right now? How many bonds does it have right now?
2.
Bache, 1, 2, 3, 4. How many bonds are there?
4.
4. How many does it need more?
2.
How many bonds can be there maximum in a carbon atom?
Um,
Maximum 4 bonds for each carbon atom. Huh? So the second carbon
okay.
atom has how many bonds, bache? 1, 2, 3, 4, right? Not
Yes,
understood.
ma'am.
Any problem? Please say. No worries. No rush.
No, ma'am. I understood.
You understood? So it can have a maximum of 4. It already has 4 bonds. It means no hydrogen bonded here, right? The third one, how many bonds does it have?
Um, 1. No,
Mm-hmm.
2. 2, 2.
Good. 2. How many does it need more? 2.
2.
We can attach 2 hydrogen atom. Now it's 4 bonds. Are there? 1, 2, 3, 4. The fourth carbon atom? 3, right? It needs 3 more. It just has 1 bond. Correct? Therefore, whenever there is more than 1 bond between carbon, it's called unsaturated. Fine? Unsaturated. Let's see, bachi, if the bond is double bond. Clearly, we can see there are 2 bonds, right? It's a double bond. It will be called as alkene. What will be called as? Alkene. Okay. If it's a triple bond, see,
Alkyne.
alkyne. Okay. Akshin, is it understood to you?
Yes, ma'am.
If there's 1 bond between carbon and carbon atom, okay, it's called saturated. See, 1 bond. It's called as alkane. So we have alkane, alkene, and alkyne. We have alkane, alkene, and alkyne. So I will draw the example here. Alkane with 2 carbon atoms. Alkene with 2 carbon atoms, right? And alkyne with 2 carbon atoms. Any problem here, bachcho?
No,
No,
ma'am.
ma'am.
Actually, why is it called as saturated and unsaturated?
Because
Mhm.
they're more bond, more or
Huh?
less. Because there are
Huh?
more or less bond between
Okay,
two.
fine. So, but when it is 1 bond, it is called as saturated. Saturated means full, right?
Yeah.
See, look here, look here. In this case, which is the alkane, we cannot have more bonds for each carbon atom here. Abdullah, bache, pay attention. We cannot have more bonds for each carbon atom here. It's already full, correct? It's already full. If we break this 1 bond between carbon atom, the compound is broken off. So there is no point of doing that. It's the maximum that we can have. In the second one, we can have it like this. Instead of, if we break this double bond between the carbon-carbon atom, okay, we can again have it like this. So it's not full. We can break that one bond in between, still the compound will be there as it is. The properties might change because of two bonds or one bond, but the compound will be there as it is. By compound, I mean two carbon atoms will be joined to each other. Yes. Respond with you.
I'm still confused. Can you tell
Okay,
again?
okay, okay. Yeah, sure. So
Like,
basically, in the in
why
the
is it
first
called
case,
saturated?
I am coming. In the first case, it is saturated, right? And the second and the third cases, they are unsaturated. Fine. Let's understand why is the first one called as saturated. Saturated means full. That means no, it's maximum, right? No other bond. Fine. So see, if we break this bond, if we break this bond, the compound will be broken off. There's no compound then because carbon-carbon bonding it's broken off, right? So here, this is the maximum number of bonds that we can have for these two carbons compound. If the compound is having these two carbon atoms bonded to each other just by a single bond, these are the maximum bonds that we can have here. Yes, without the
Yes.
compound being broken off. Therefore, it is full to its maximum capacity. By full, we mean, maximum bonds are already present. Now, if we see the second case, if we break this bond, bache, it will become this. Still, the carbon-carbon bonding is there. But still, if we break this bond, so one hand for this one and one hand for this one gets freed. It had two here, right? Now it can have one more bond for each carbon atom. Are you getting it?
Yes, yes.
So it is still not full. Okay. Therefore, it is called as unsaturated. And for the third one, you see, we can have it like this. It just had one bond before, one free hand. Now it will have two. We can also have it like this. Now it will have three. Afshin, is it understood?
Yes, ma'am.
Any problem, please let me know. Both of you.
No, ma'am, it's clear.
Okay.
It's
So
clear.
that is why these are called as saturated and unsaturated. You will see the chemical reactions when in class 11 for the alkenes and the alkynes, and this is exactly what is happening. We are breaking that bond in between. The double or the triple bond is being broken to form the single bond between them, and more, bonds are being attached to the carbon atoms. Right? That is why they are called as saturated and unsaturated, respectively. Any problem?
No, ma'am.
Therefore, alkanes are saturated and Abdullah, what is unsaturated? Alkenes and
Alkynes.
are unsaturated. How many bonds are there in alkynes?
Three.
So one carbon atom is having just three bonds. Are you saying that?
Yes. No, no,
No.
no. Two,
Hmm.
two. Both of them.
No. No. Yeah. Basically, how do we define alkenes, alkynes, and alkanes? Number of carbon bonds between carbon-carbon atoms. So if you are saying alkyne, the compound is alkyne. That means two carbon atoms are having three bonds between them. Understood?
Yes. Yes.
Fine. Now see, so this is one way of figuring out what type of compound we can have. We saw that we just in one when we are having two carbon atoms, we can have three different types of compounds based on its saturation level. Now let's see the next thing. The second part is number of carbon atoms present in the compound. We know that carbon-carbon linkage is very strong. Carbon can bond to any number of carbon atoms. We can have any number of carbon atoms in the chain. Okay. Therefore, let's see what type of numbers are present. I mean, how many numbers are present and what type of compound do we get based on that. Okay. So see, the first one here is meth. Meth means one carbon atom. You will always have to use these things. Always. Whenever we are having a compound, meth, eth, prop, bute, these are the basic names. Okay. The root word of the compound. So one carbon atom. Meth means one carbon atom. Two, that is eth, means how many carbon atoms? Two carbon atoms. When we are having three carbon atoms, we will call it prop. Bacha, you getting it?
Yes.
Afshin?
Yes, ma'am.
This will
Butane, four
also be used in another thing, right, ma'am?
Yes, yes, this is used in everything.
No,
That
that
is like that.
butane and propane thing.
See, basically, when we are having a compound, we can have any number of carbon atoms in that compound. The name of that compound will come from this, how many carbon atoms are present in that compound. And to determine the name, we will be using these words which we are saying. If the compound, let's suppose we have any random compound which is having four carbon atoms, okay? So we will have in it bute, right? Bute indicates what? Four carbon atoms are present in the compound. I hope that is what your question was.
No, no, like uh, we will use this for another thing, right? Like methane, ethane, butane, and that thing. I just can't remember its name.
Okay, I'm coming to that. I'm not able to understand your question like very properly, exactly what you're trying to ask. So let's come on to that. Pent means five carbon atoms. Hex, six carbon atoms. Hept, how many carbon atoms? Seven. Oct, eight carbon atoms. Nine carbon atoms. And dec, we have 10 carbon atoms. Till nine, it's fine with you. 10 carbon atoms. Okay. Now let's go with the naming of the compound. Next. Haji, how many carbon atoms are present in this compound? This is a compound. How many carbon atoms?
Three.
So three means prop. And what kind of bonding is there? Saturated or unsaturated?
Saturate.
Saturated.
So alkane, right? So I will use ane. What is the compound name?
Yes, this is what I meant.
I got it. Propane. Okay. This is propane. Nothing. Afshin understood?
Yes, ma'am.
No, not understood. Huh?
No, I did understood.
Let's see this. So what will be the name of this compound, bache? How many carbon
E-
atoms?
Ethane.
Good. Ethane. Okay. So this will be hydrogen, hydrogen. I'm just taking the basics today. Okay. In the next class, inshallah, we'll be studying all of this in a very systematic manner. Okay. Through the formulas and everything. Today, I'm just trying to get you the basics. Uh, what is this then? Hanji. How many carbon atoms?
Methane. Methane.
Methane. Excellent. And if you must have learned the formula before for methane, that was CH4. So one carbon atom bonded to how many hydrogen atoms?
4.
4. So that becomes CH4. Understood? Um, okay, try to make the structure for pentane. Try to make it, all of you, both of you. Pentane. Abdullah,
For pentane, how much do we have to use?
you will see it. I've given you the list. Use that. I'm not going to tell you now. Use that
I,
list.
I,
And you have not
I
written that.
didn't learn it.
Why?
No,
Why don't you write, bache?
I write, but not everything, ma'am. Because
And this is important.
in my book,
School
class book, I've
notebook.
written it.
Okay, so get it? Get it? Wait.
Then
Okay. So how many carbon atoms have you used?
5.
5. So for the first carbon atom, how many hydrogen atoms?
3.
Say the second,
2.
the third,
2.
the fourth,
2.
2, and the fifth,
3.
3. I hope that is understood.
Yes, ma'am.
Yes, Abdullah. Abdullah is not using the microphone. Yes, Abdullah, see. So how many carbon atoms?
5.
Quickly draw the structure. quickly. Afshin, did you get this?
Yes, ma'am.
Good. Abdullah has got stuck. Come to the next one. Let's say, hello, Abdullah, is it okay?
Yes, just 1 second, ma'am. I'm doing.
Okay, okay. You got stuck so badly. I think our network is fluctuating again.
I think so.
Abdullah, this is what you have got? Fine. The first carbon atom having 3 hydrogen atoms, the second having 2, but just not clearly visible. The third also having 2, the fourth also having 2, the fifth also having 3. Okay, fine. Now draw this one. Be very careful. So how many carbon atoms? 2. Okay, H refers to 2 carbon atoms. Now, what is the nature of bonding between these 2 carbon atoms, both of you? What is the nature of bonding between these 2 carbon atoms? What is the nature of bonding between these 2 carbon atoms? Both of you, please respond. Ah, how do we know? How do we get to know the bonding nature of bonding? See, what is it? In. In means how many
Five.
bonds?
2.
Excellent, double bonds, right? So
Yeah.
that means there are double bonds between these 2 carbon atoms. Now see what will be the structure like. How many hydrogen atoms needed by each carbon atom?
4.
In total 4. Or each
Yeah.
carbon atom.
No,
Each
in
carbon
total.
atom. Good. So 1, 2, 3. Abdullah understood?
Yes.
Acha, tell me, can we have methane? Can we have methane?
No.
Excellent. We cannot have.
No, it's not possible.
Excellent. Because E means double bonding between 2 carbon atoms. In meth, we just cannot have 2 carbon atoms, right? Therefore,
Yes, ma'am.
methane is not possible. Ethene is the smallest uh, what alkene group. Okay, alkene compound. I hope that is understood. Now, see, if I tell you to draw heptene, heptene, what does that mean? Hept means 7 carbon atoms. So let's draw 7 carbon atoms. 1, 2, 3, 4, 5, 6, 7. Yes. Abdullah, any problem? Any problem, Abdullah? Abdullah, I'm asking you something. Any problem?
And yes, ma'am.
What is happening?
I'm having some issues right now, ma'am. Yes,
What
can
is
you?
it?
Network issues.
No, it's not really network issues. It's something else. Something else happening in the background. You're not very attentive because of that.
No, no, it's network issues, ma'am. My laptop keeps getting stuck.
Yes. So for heptene, what we will have? Now tell me, what 7 carbon atoms have drawn. What is the nature of bonding here?
Three.
It's a ene. It's ene, right? So ene means alkene.
Okay, ma'am.
Two,
Alkene means
two.
bonds, double bonds. Where should I draw these double bonds?
Middle,
See,
anywhere from like middle to
in this
left or right.
case, in this case, whenever we don't have anything mentioned as such on which carbon atom do we need to draw, okay? The end carbon atoms, which are called as the terminal carbon atoms or the end carbon atoms, okay? Both of them are terminal or end carbon atoms, right? We can draw it from either side. So here I can draw it like this. Now, based on that, we will have to decide how many hydrogen atoms do we need, okay? So let's quickly decide. For the first carbon atom, how many hydrogen atoms needed?
One.
Huh? Why one?
Oh,
It is just having 2 bonds. How many hydrogen atoms? 2, right?
No.
For the second one,
one.
One.
good. 2, 2, 2, 2, 2, 3. Correct?
Yes.
Yes.
Understood?
Yes, ma'am.
Yes.
Okay. Draw propene. Acha, wait. Draw this. Bute means 4 carbon atoms. It is butene, right? Ine means what is the nature of bonding?
Unsaturated.
Huh? But what is the nature of bonding? Ine refers to?
Unsaturated.
That's right. But how many bonds in unsaturated also? Triple, right?
Triple. Yeah.
Triple bonds in what? Between what?
Between the carbon bonds.
Between 2 carbon atoms. Good. Correct? Now we have drawn 4 carbon atoms because that was the question. Bute refers to 4 carbon atoms. Now see again, we will pick any one of the terminal carbon atoms. Yes, Abdullah, but it's not visible. Any one of the carbon terminal atoms, okay, and see how many bonds do I need to draw? 3. Now for this becomes the first one. Whichever terminal carbon atom I'm starting to make the this ine or ene, whatever is given, okay, that will become the first carbon atom. So in the first carbon atom, how many hydrogen atoms needed now? Both of
It
you?
can be either in the left side or right side, right?
Yeah, either side we can choose, okay. But whichever side we have chosen, that becomes the first one, okay. Now,
Okay.
so the first carbon atom, how many hydrogen atoms needed now?
Can you repeat, man?
The first carbon atom now needs how many hydrogen atoms?
One.
One.
Excellent. The second one will need how many hydrogen atoms?
None.
One.
1, 2. Hanji Afshin. So
Ma'am,
One,
one,
ma'am.
two,
One.
three,
wait.
4. How many bonds does it already have?
Sorry, zero, zero.
So it needs no.
One. Yes. The third one will need 2 hydrogen atoms, right?
Yeah.
And the fourth one?
Three.
3. Is that understood to both of you? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. So then I'm stopping it.
Ma'am,
Yes.
that terminal end that we draw,
Hmm.
can we draw it on the other terminal end as well,
Yes,
or
yes,
only
yes.
on?
We
Okay,
no,
ma'am.
we can choose it from either of the sides, but whichever side we have chosen, that will become the first carbon. Okay?
Okay, ma'am. Okay. Okay.
Okay. But please revise these. Inshallah, in the next class, we'll continue it in the systematic manner. Today, I just discussed some of the basic concepts. Okay? Thank
Okay. Thank you, ma'am.
you. Afshin, you wait for a second.
Bye,
Abdullah, you
ma'am.
may leave. Hmm. Afshin, uh, Bache, if you have it on from the 3rd of December, we will have to continue from the 4th chapter, right? I mean, from the 3rd chapter. Is it not possible for you to join if we have the class timings, at around reduced by 2 hours? If we have it before 2 hours, then the schedule time.
Ma'am, I guess I won't be able to.
Okay, let's see what can be done then. Okay, I'll talk to the team. Thank you.
Okay, thank you, ma'am. Bye.
हाय नबील, अस्सलाम वालेकुम। कैसे हो आप? हेलो।
Hello. Yes. Assalamu
यस नबील,
alaikum.
कैसे हो आप? वालेकुम सलाम। ठीक हो?
Yes.
चलो, गुड। एक सेकेंड। ओके नबील, लास्ट क्लास में हम लोग सिमेट्री स्टडी कर रहे थे, राइट? सो एक सेकेंड, जस्ट गिव मी अ सेकेंड मुझे। ठीक है। ओके नबील, सो लास्ट क्लास में हम लोग स्टडी कर रहे थे, तो पैरेललोग्राम तक हमने डिस्कस कर लिया था। नाउ लेट्स डिस्कस द रोम्बस, ट्रेपीजियम एंड काइट। ठीक है, रोम्बस के बारे में डिस्कस करते हैं। रोम्बस में आपकी 4 साइड्स इक्वल होती हैं, बट आपके
Okay.
डायगोनल्स इक्वल नहीं होते हैं। ठीक है,
Means
डायगोनल्स एक दूसरे को बाइसेक्ट करते हैं 90 डिग्री पे, यानी कि ये वाला पोर्शन आपका, लेट मी जस्ट राइट इट। सो ये वाला डायगोनल इसके बराबर होगा, ये वाला डायगोनल इसके बराबर। चारों एक दूसरे में बराबर नहीं होंगे, पेयरिंग में बराबर होंगे। जैसे आपका पैरेललोग्राम था, वैसे ही इसमें
okay.
होगा। ठीक है, अब यहाँ पे इसमें
Okay.
कितनी सिमेट्रीज आ रही है नबील? 2 सिमेट्री आ रही है।
Yes.
लाइन्स ऑफ
Char.
सिमेट्री दो की, नहीं नहीं, बेसिकली 2 आ रही है ना, एक ऐसे, एक ऐसे।
Okay. Okay. Okay.
ठीक है, और रोटेशन भी 2 ही होंगी, राइट?
Okay.
क्लियर है? अब बात करते हैं दूसरी, विच इज ट्रपीजियम। ट्रपीजियम सबसे ज्यादा नॉर्मल फिगर होता है, इसमें कुछ ज्यादा है ही नहीं। पहली बात ये, 2 लाइन पैरेलल होती हैं बस, इसमें ये डिफरेंस होता है। अब नबील, ट्रपीजियम को इतने हिस्से में बांट दो, क्या ये दोनों बराबर हैं? देखो, इसकी साइड थोड़ी सी छोटी है, ये साइड बड़ी है।
I don't think this has a line of symmetry at all.
यस, सो देयर इज नो लाइन ऑफ सिमेट्री, और रोटेशनल सिमेट्री भी एक ही है इसकी। या तो आप इसको फ्लिप कर दो, तो बस वो रोटेशनल सिमेट्री आएगी, अदरवाइज कुछ नहीं है
Like
इसमें।
inverted or flipped.
फ्लिप फ्लिप मतलब बेसिकली इन्वर्टेड, उसको फ्लिप को ही मैं इन्वर्टेड बोल रहा हूँ इन द सेंस।
Okay.
ठीक है,
Okay.
बात करते हैं काइट की। काइट बड़ी सिमिलर है आपकी रोम्बस से। अब इसमें क्या है, आपकी 2 साइड्स बराबर होती है एडजेसेंट वाली, जैसे कि ये साइड इसके बराबर है और नीचे वाली साइड बड़ी है, वो इसके बराबर है। डायगोनल्स इसमें भी बाइसेक्ट करते हैं 90 डिग्री पे, बट चारों एक दूसरे के बराबर नहीं होते हैं। ठीक है, आप इसमें भी बेसिकली
Okay.
देखो नबील, लाइन ऑफ सिमेट्री देखो, सिर्फ एक ही है, क्योंकि अगर आप काइट को यहां से कट करोगे तभी बराबर एकदम एग्जैक्ट शेप मिलेगी, लेकिन आप
So
यहां
why
से
is
कट
there a
करने के,
line over there?
कहां पर मतलब?
Why is there a second line the kite में?
नहीं, वो
Cutting the
डायगनल्स
triangle.
दिखा रहा है, डायगनल्स दिखा रहा है,
Okay.
डायगनल्स। हाँ, अब देखो, अगर आप यहां से कट करोगे नबील, कोई सिमेट्री बन रही है? नहीं बन रही है।
No.
सिमेट्री सिर्फ बीच में से बनेगी, यहां से। ठीक है, और इसका ऑर्डर ऑफ सिमेट्री भी 1 ही होगा। बोलो, आपको यहां तक क्लियर है या नहीं नबील? प्लीज डू लेट मी नो।
Yes.
इतना ही बेसिक सा था, ज्यादा कुछ खास है नहीं इसमें, आपको बस बताना था कि भाई लाइन ऑफ सिमेट्री क्या है, रोटेशनल सिमेट्री क्या है। ठीक है, समझ में आ गया लाइन ऑफ सिमेट्री एंड रोटेशनल सिमेट्री कैसे डिस्कस करते हैं?
Yes. I don't understand the diagonals though. What is it exactly?
डायगोनल्स बेसिकली जो चारों साइड्स को कनेक्ट करते हैं। यहां से अगर मैं एक साइड, एक ये ले लूं, एक डायगोनल ये हो गया, एक इस पॉइंट से इस पॉइंट तक ले लो, दूसरा डायगोनल ये हो गया। डायगोनल मींस आपका कनेक्ट जो है, जैसे इसमें डायगोनल ये वाले हो जाएंगे आपके। ठीक है,
Okay.
हाँ, डायगोनल्स मींस जो ऑपोजिट पॉइंट्स है
So a
उनको कनेक्ट
singular
करना।
point which connects the four sides.
नहीं नहीं, चारों साइड्स कहाँ, ऑपोजिट पॉइंट्स कनेक्ट्स ईच अदर। ये इससे
Okay.
कनेक्ट हो रहा है, ये इससे कनेक्ट हो रहा है, ऑपोजिट पॉइंट से डायगोनल्स ड्रॉ होते हैं, ठीक है।